we are going to solve equations using completing the square. And so sometimes we have a quadratic that looks a little funny or isn't factorable. And so we usually would set this equal to 0 and try and factor it, but that's not going to work anymore. So what we're going to do instead is we're going to move the constant over to the other side. And then we're going to figure out what we need to add to this so that we can create a perfect square trinomial on the left. So we're going to take our number here, cut it in half, and get 3. We're then going to take that number, this is big B, remember, so big B squared then is 9. And so I'm going to add 9 to this side, but if you remember, we can only add 9 to one side if we also add it to the other. This side now factors as x plus 3, we just take that plus 3 and pop it right in, squared, perfect square trinomial. Minus 1 plus 9 is 8. At this point, we can use the square root property, and when we square root a square, we get what's inside, and we get plus or minus. Square root of 8 is 2 and 4, so a 2 comes out and a 2 stays in. And then we subtract the 3 over, but since we know the sign of the 3, we leave it in front. So x equals minus 3 plus or minus 2 root 2. Or we could write this as x equals minus 3 plus 2 root 2, or minus x equals minus 3 minus 2 root 2. And there's our 2-answer solution. I want to show one more example of this just to help make sure it's visible. Plus, this one has another catch. So we have 3x squared plus 6x plus 5 equals 0. And so what we're going to do first is we're going to subtract the 5 over. So we get 3x squared plus 6x equals minus 5. We then only want to complete the square when this is a 1. So we're going to divide all numbers by 3. So we're going to get x squared plus 2x plus blank equals minus 5/3. Now we complete the square, so we take our middle number 2. Big B is 2 divided by 2, which is 1. So b squared is also a 1. So we're going to add a 1 here, and I'm going to add a 1 here, but because it's in fraction form, I'm going to add it as a 3/3. So we get x plus 1 squared, because this factors. It's now a perfect square trinomial. That's why we complete the square on it. Equals minus 2/3. Now when I take the square root of both sides, notice that this time around we get x plus 1 equals I plus or minus root 2 over root 3, which we don't like. We need to multiply this, we need to rationalize it. Root 3 over root 3. So this is really plus or minus root 6I over 3. That's a 6, not a b. Then we subtract 1, and so we get, x equals, let's give ourselves some more room, minus 1 plus root 6 over 3i, or x equals minus 1 minus root 6 over 3i. And here are our two answers. And so we can use completing the square to solve non-factorable quadratic trinomials.